Hi everybody, this is Ms. Black. We are in Open Campus Math 099 and we are now at Module 16. And you guys are going to find out today the last 12 weeks of work that we've been doing in 099. We've been learning how to do addition, subtraction, multiplication, and division of polynomials, fraction, rationals, and square roots, radicals. And we're going to take all these operations along with factoring and we're going to actually use it. So this next module begins, why do we need to know order of operations? Why do we have to know how to do all these things we've been learning? And today's module is about solving quadratic equations. So the first thing we got to go back to do is talk about what makes something in algebra an equation. Okay, everybody should know by now that if you look at all the work we've done, there has not been an equal sign in anything. There's been adding, plus, there's been subtraction, there's been parentheses for multiply, there's been a fraction bar for division, there's been a square root symbol. There has not been at one time yet an equal sign. Because an equal sign means something is an equation. And an equation is in real life the same thing it is in math. I'm going to give you two analogies to think about an equation in real life. If you're one of those people that likes to go to the gym and you like lifting weights, well, think about it. If you put 10 pounds on the right side, you're going to put 10 pounds on the left side. Weights are an equation because it has to stay balanced to work. If you're like me that has kids, especially young kids, you take them to the park. One of the great things about the park is the seesaw or the teeter-totter. Well, again, a seesaw or teeter-totter is an equation. It doesn't work unless the left side and the right side are balanced. How many times have you been to the park and seen a kid sitting on the seesaw on one side and he says, "Mommy, it's not working," because it has to balance. So that's what the equal sign does. The equal sign says what's on the left is equal to what's on the right. It means the same thing. And that's what we're going to talk about. Now, our goal is to learn how to solve a new equation in 099. But before I do that, we got to go back and review what you learned in 098 about solving equations. So let's go to the board. Okay, guys, if you look, this is an equation. There is an equal symbol, and that means you're separating into the left side and the right side. This equal symbol is like a wall. It separates the two sides of an equation. Now, with an equation, the directions are different. You may have heard all semester me say simplify. Simplify the expression. That means do the operation you see. Follow, please excuse my dear Aunt Sally. Equations have their own set of directions, and the word for equations is to solve. Solve means one thing and one thing only. Figure out what number goes in place of this letter to make this balance. Now, sure, some of you be able to look at this equation and say, "Oh, I know what number goes here. I know what, if you multiply it to 2 and then add it to 8, what would make 0?" And that's great. But you're going to find out you can't always look at the equation and figure out that number in your head. There's got to be a procedure. Solving equations is like being a doctor. You have to learn the correct procedure and do it step by step. So you're going to see me today do a lot of work on paper because this is not something anymore you're allowed to just do in your head. It's got to be shown step by step what you're doing. Solve means to isolate the variable. So no matter what level of algebra you're at, whether it's Algebra 1 or it's all the way to college algebra, if you have an equation and you're told to solve, your job is very simple. Get that x by itself. Isolate it. It doesn't want to be with anybody. So if we're going to get x by itself, we're going to have to move the 2 and the 8. But you can't move them at the same time because they're connected by different operations. So you can only move one term at a time. The question is, who do you move first? Do you move the 2 first or the 8 first? Well, you should have learned in 098 that you always move the terms furthest away. So look, here's x. It's right next to 2. They're side by side. They're kissing. That's multiplication. We're not going to move them yet. This 8 is connected by adding. Think about it. I know this is crazy, but think about it like getting undressed. When you're ready to come home from work and you're getting undressed, what do you take off first? Do you take off your shirt or you take off your shoes? You're going to take away the piece that's furthest away. So the same thing in algebra. When we're solving an equation, you move the numbers furthest away. The way you move the numbers you learned in 098 is to do the opposite operation. The opposite of adding 8 is subtracting 8. And just like lifting weights, if you take 8 pounds off the left, you got to take 8 pounds off the right to keep balance. So you have to show that you're doing that on both sides. You'll bring down the 2x. A plus 8 and a minus 8 make 0, but is there any need to write plus 0? No, that means there's nothing there. So you've heard before, when you add opposites, our vocabulary word is additive inverses, they cancel out. And on the right side, 0 minus 8 is negative 8. You know you're not done solving because, again, look, is your variable by itself? No. The opposite of multiply by 2 is to divide by 2. And that's why we use the fraction bar. If we divide by 2 on the left, we divide by 2 on the right to keep balance. 2 divided by 2 is 1, but we don't need to write a 1x because 1 is connected by multiplication. So it's understood to be there. 8 divided by negative 2 is negative 4. So when you solve an equation, that's what you should get. You should get a solution, a number. This kind of equation in 098, Algebra 1, was called a linear equation. And it's called linear because it should only have one solution. This x has an invisible exponent. From the beginning of the semester, that exponent's understood to be 1. So when the exponent's a 1, you only get one answer. Now, an important thing about solving equations is you should always know if your answer is right or wrong. You should be able to check it. So it's very important you learn how to always check your answers. When you check an equation, you write the original one I gave you. And then what you're going to do is take this number you got for x and substitute it in. Replace it. So all you're going to do is copy this equation. Except for x, you're going to put negative 4. And because they're side by side, we know they're connected by multiplication. We put our parentheses. Now you're not done. If this is truly a check, it should balance. Checking an equation is like in real life checking your checkbook. You should add up all your debits, add up all your credits, and hope they balance. You don't move anybody. Think about that. If you moved your debits to the credits, we'd all be rich. So when you check, nobody moves. Here's the equals, here's the wall. You work out the left side to become one number, you work out the right side to be one number, and you hope they balance. So on the left, 2 times negative 4 is negative 8. Negative 8 plus 8 is 0. On the right side, we already have a number. It's 0. 0 equals 0. That's true. It checks. That's our solution. Now, you're thinking, well, I've already learned how to do this. That's right, you have. This was 98, solving a linear equation. You get one solution, you check to make sure it works. I'm going to step you up now. Our job in 99 is to learn how to solve a quadratic equation. So first of all, you're going to have to be able to recognize with your eyeballs what makes an equation quadratic. So let's go to your notes, and let's see that definition. Okay, if you look at your notes, the definition says, a quadratic equation is in the form ax squared plus bx plus c equals 0. It has an equal sign, which means it's an equation. But if you look, the reason why it's a different equation, it's quadratic and not linear, is because it doesn't have x to the first power, it has an x squared. So if your equation has an x squared, it is called quadratic. What's the name of it? Quadratic. So those are all examples of quadratics. X squared minus 4 equals 0. There's the x squared. 3x squared plus 7 equals 28. There's the x squared. 6 equals x squared. There's the x squared. Now let's go to the board and look at that last one. Because when I read x plus 2 squared equals 0, I don't see the x squared. So let's think about that. If I write x plus 2 squared equals 0, that x has an exponent of 1. So right now it's not quadratic. However, from the 12 weeks of us working in these modules, we all know squaring means to write it how many times? Twice. And when I write x plus 2 times x plus 2, I'm asking you to do multiplication. When you multiply a binomial times a binomial, what's that new method we've learned? Correct, it's FOIL. What does F stand for? Good, the first. And as soon as you multiply x times x, guys, what do you get? X squared. So this equation will be quadratic because it will have an x squared after you multiply. So that's the first thing. You have to know we're dealing with a new equation. This square matters because now we're not going to have one solution, we're going to have two. Remember we talked about the degree of the polynomial? The degree was your highest exponent. So if we FOILed all this out, there's your first, your outers would be 2x, your inners would be 2x, your last would be 4. Okay, we collect like terms like we always do with FOIL. 2x plus 2x would be 4x. And if you look at that equation, it's an equation because it has an equal sign. It's quadratic because it has an x squared, which guarantees you're going to get me two answers. Now, there's a catch. Let's go back to the notes. And the catch is how to solve a quadratic. There is not one foolproof method that works, unfortunately. So we're going to take all these modules, all this information we've covered, and use it to solve quadratics because there's 4 ways to solve a quadratic. And we're going to go through each one in a different module. Today we're going to work on factoring. And as you'll recall, factoring was way back in chapter 13. So we're going to actually use our factoring skills to actually solve something, to get an answer for something. We're no longer going to factor just for the sake of factoring. Okay, so let's go up to the board and let's work a couple of quadratics by factoring, and let me show you what I mean. You will see we will use everything we've learned. One of the reasons why college math is so difficult is because you've got to keep refreshing your facts. Okay, I'm going to work example 1 in your notes. The equation is x squared minus 4 equals 0. So, I want to solve this. Solve means I want to know what number goes in this spot to make this balance. I don't want to hear anymore that you can guess at it. That's not acceptable. You have to show a procedure on how to arrive at the result. So, I'm going to walk you through the procedure. The first thing to solve a quadratic equation is your equation's got to be set equal to 0. You want all your terms on the left and 0 on your right. So this one's ready to go. Step 2 then is to use your factoring skills. We've learned 3 major ways to factor that you're going to hear all the time. We've heard GCF. We've heard difference of perfect squares. And we've heard the trinomial rule. So guys, we're going to use all that info from our modules on chapter 13. So I'm going to ask you, what rule of factoring is this? Is this GCF? Can you divide x squared and 4 by the same thing? No. Okay? Is it difference of perfect squares? Difference has a subtraction symbol. Perfect squares are something times themselves. 4 is a perfect square. X squared is a perfect square. Yes. So we're going to factor this doing difference of perfect squares. So we took 2 parentheses and we keep the equals 0. If you do not write the equals 0, you are wrong because then you're not writing me an equation. That equals, that side's always got to stay. So let's factor this. What multiplies to x squared? X times x. What's multiplied to 4? 2 times 2. To multiply to a negative 4, one's a positive, one's a minus. What you have just done is a magic trick. If you look, no longer are these x squareds. They are x to the first power, x to the first power. They are no longer quadratic. They are linear. How many x's do you have here? 2. So step 3 is now you're going to write me 2 linear equations. So you'll take the first parentheses, x plus 2, and set it equal to 0. You'll take the second parentheses, x minus 2, and set it equal to 0. Now you're back to Algebra 1. So you've just done magic. You've taken a new equation you've never seen before. You use something I've taught you previously, factoring, to make Algebra 1 linears. And now we'll solve each. So one solution is 0 minus 2 is negative 2. The other solution, if we add 2, is x equals 2. You could leave the answer like that. You could write x equals negative 2, comma 2. Or if you want to be really fancy, there is a symbol that says the answer is both negative and positive. It's called the plus or minus symbol. And you could say x equals plus or minus 2 to show there's two solutions. So you have to memorize these steps. You've got to learn when we solve a quadratic equation. We set it equal to 0. We factor it using one of our rules. We'll always get two x's, so we'll write two linear equations and solve them. And that's all there is to it. But you're using everything you've learned. Now, to prove to you you're right, I'm going to check it. And it's very important that you guys realize you need to check your solutions. To check, you always go back to the original. So there's the original equation. X squared minus 4 equals 0. You can only check one of these answers at a time. So let's check the positive 2 first. So we would write, instead of x, we'd write positive 2 squared minus 4 equals 0. Then we'd follow order of operations and work this out. 2 squared is 4. Not done yet. 4 minus 4 is 0. 0 equals 0, it checks. Just because the first answer checks doesn't guarantee the second one will. You've got to check each one separately. So again, we go back to the original, and now we're going to check the negative 2. So instead of writing x squared, we're going to write negative 2 squared. And remember, from way back in our first couple of modules, you've got to put that in parentheses to show you're doing the whole thing. Minus 4 equals 0. Negative 2, if you square it, is negative 2 times negative 2, which is positive 4. 4 minus 4 is 0, and 0 equals 0. It checks. So because they both check, they are both the right answer. You don't play eeny, meeny, miny, mo, and pick which one you want. They are both the solution. In real life, you could have two answers to a problem. And that's the procedure. So what's going to make this difficult? What's going to make it difficult is the more difficult the word problem looks. This can become really lengthy. So let's look at another example of an equation in our notes and see how much more work's involved. So if y'all would look at example 3 in your notes. Example 3 in your notes says x plus 3 times x plus 8 equals x. All right, it's an equation. It has an equal sign. Right now, it looks linear. That's x to the first, that's x to the first, that's x to the first. Okay, it looks like it's good old Algebra 1. So the first thing is going to be like, where do we start? Well, guys, you got to use what you've learned in the past as well as what I've taught you. Even if you wanted to move this x to the left side and set it equal to 0, you can't. Why can't you move the x? Because look, the left side is stuck in parentheses. So you should have learned in 098 in Algebra 1, before you ever start moving terms in an equation, you have to get everybody free out of parentheses. So the only way to get rid of parentheses is to do multiplication. Now everybody look closely. I want you to multiply x plus 3 times x plus 8. What do you have to use? That's right. It's a binomial times a binomial. You got to use your FOIL method. So here we go. What's first? X times x is x squared. Outers, x times positive 8, positive 8x. Inners, 3 times x is positive 3x. Last, positive 3 times positive 8 is our positive 24. Remember, if you put your eyeballs, there's your little smiley guy. And that still equals x. So there's where you had to learn what we learned in the beginning of the modules from chapter 12. You got to know how to multiply binomials. Now if you look, we're supposed to collect like terms. These are alike. They have the x. So we write x squared plus 11x plus 24 equals x. Everybody look closely. What do you have in this equation now? You have an x squared. That means it's quadratic. It's not an algebra 1 equation. It's an algebra 2 equation. It's quadratic. So as soon as you see the x squared in your equation, you got to think, okay, steps. First step, she said, set it equal to 0. So this x now can move because there's no parentheses. How do you move an x? You do the opposite, you subtract it. Where are we going to put this x? Are we going to put it underneath the x squared? Are we going to put it underneath the 24? No, we're going to put it underneath what's alike. Because in add and subtract, you have to put together like terms. So we bring down the x squared. 11x minus 1x is 10x plus 24 equals 0. So right now we've used everything from our chapter 12, our beginning modules, understanding how to multiply, understanding about exponents, understanding how to put together like terms. Once you get here, after your quadratic equation is set equal to 0, your job is to factor. There's our chapter 13 modules. Well, which rule is it? Is it GCF? Nope. All three terms don't have anything in common. Is it difference of perfect squares? No, it's not a binomial. How many terms are here? 1, 2, 3. This must be our trinomial rule of factoring. So we put two parentheses, and we think backwards. What multiplies to x squared? X times x. What can multiply to 24? Well, there's lots of options. 1 and 24, 2 and 12, 3 and 8, 4 and 6. You can't just go eeny, meeny, miny, mo. We've talked about that in chapter 13. You want to multiply to 24 and add to 10. Will it be 1 and 24? Nope, that adds to 25. Will it be 2 and 12? Nope, that adds to 14. It says add, not subtract. Will it be 3 and 8? That adds to 11. Will it be 4 and 6? Yes. 4 and 6 add to 10. And to add to a positive, the signs of both have to be the same. So what you've done is a magic trick. You went from being squared to being x and x. So now there's not one equation, there are two. These are now back to algebra 1. These are linear equations. So we're going to solve them. So we're going to take x plus 4 and set it equal to 0. We're going to take x plus 6 and set it equal to 0. And now you're just doing good old algebra 1. Move your constant by subtracting. There's your first solution. Move your constant by subtracting. There's your second solution. How many solutions should quadratic equations have? That's right, 2 solutions. There's no guarantee one answer is going to be positive and one answer is going to be negative. They could both be positive, they could both be negative, they could be one of each. One could be a whole number, one could be a fraction, a decimal. It could be whatever. But you should have 2 solutions. If you want to know if you're right, you're going to check them. When you check them, you go back to the very original equation I gave you. So we go back to here. Again, you can only check one of these answers at a time. You can't check both. So let's start with the negative 4. Wherever there is an x, we're going to put a negative 4. So there's an x. We're going to write negative 4 plus, bring down the 3. There's an x. We're going to write negative 4 plus 8 equals. There's an x. We're going to write negative 4. Now, guys, look. These are numbers. We don't FOIL numbers. We just do what's in parentheses. Negative 4 plus 3 is negative 1. Negative 4 plus 8 is 4. We're not done yet. There's not one number here. This is connected by multiplication. Negative 1 times 4 is negative 4. Does negative 4 equal negative 4? Yes. This is a solution. It checks. We're not done, though. You have another solution. So we do it again. We go back to the original. Wherever there's an x, we're going to replace it with, substitute in a negative 6. So we're going to get negative 6 plus 3. Parentheses, negative 6 plus 8. equals, there's an x, negative 6. Let's work it out. These are numbers. Negative 6 plus 3 is negative 3. Negative 6 plus 8 is 2. If you look, I'm not moving any numbers. They're staying on the left side. They're staying on the right side. All I'm doing is seeing if they balance. Negative 3 times 2 is negative 6. That equals negative 6. It checks. So both of these check. They're both the solution. So the answer to this equation is both x is negative 4 and x is negative 6. So what you really need to do is go over these steps. How do I solve a quadratic equation? It's quadratic because what does it have in it? An x squared. To solve it, step 1 is the equation's got to equal 0. Move everybody to the left. Step 2 is once all the terms to the left, I factor. Step 3 is when I factor, I'm going to write me 2 equations, and they're both going to be algebra 1 linear, and we'll solve both. Okay, I'll catch you in the next lesson.